Hi everybody. So I just wanted to talk about mainly section 11.1 in this video. So chapter 10, remember, was inferences on one sample. So the main difference in this chapter is we'll perform inferences or try to draw conclusions based on two samples. So we'll basically be comparing samples in this case. So let's take a look at section 1.1, or 11.1 I mean. So section 11.1 then is about inference about two population proportions. So we'll be comparing two population proportions in this case, or P. So these will be the objectives that we'll look at in this section. We'll distinguish between independent and dependent sampling, whether there's some dependence between the samples that are drawn or not. We'll test hypotheses regarding two proportions from independent samples. We'll construct confidence intervals for differences between two population proportions, and then we'll test hypotheses again with two proportions from dependent samples, and then we'll determine the sample size necessary for estimating the difference between two population proportions. So let's look at objective 1 here first. So objective 1 is about distinguishing between independent and dependent sampling. So a sampling method is independent when the individuals selected for one sample do not dictate or influence or affect which individuals are to be in the second sample. And then a sampling is dependent when the individuals selected to be in one sample are used or have some influence to determine the individuals that are to be used in a second sample. So dependent samples are often referred to as matched pair samples. So for example, you might have twins where a test is done on each person, or you might have a situation where one sample is drawn and then another sample is drawn from the same person later. So it's possible for the individual again to be matched against him or herself. So just as an example of this, let's see if we can determine which one is independent and which one is dependent sampling. So let's say that a researcher wants to know whether the price of a one-night stay at a Holiday Inn Express is less than the price of a one-night stay at a Red Roof Inn. So she selects 8 towns where the location of the hotels is close to each other and determines the price of a one-night stay. So I guess the question is this an independent or dependent sample? So this should be a dependent sample, right, since the Holiday Inns can sort of be matched by town, right, so the effect of, so the price of one hotel in the same town might affect the price of another hotel in the same town. So the first example here would be dependent. To look at the second example, let's say that a researcher wants to know whether state quarters have a mean weight that is different from traditional quarters. So he selects 18 state quarters, in other words, quarters with the various states on them, and 16 traditional quarters, and compares their weights. This would be independent, right? So because the state quarters, whatever state quarters are picked, should not have an effect on what the traditional quarters that are being compared. And usually in dependent samples, you might have the same number of samples, although I guess doesn't always have to be the case. And then for independent samples, you may have a different number of samples, like in this case you've got 18 in one case and 16 in the other, although that's not necessarily set in stone. So that finishes objective 1. So let's look at objective 2. So here I said, like I said, the first example is dependent and the second sample is independent. So if you look at objective 2, hypothesis tests regarding two population proportions from independent samples. So we'll look at independent samples first, and then we will look at dependent samples. So just be aware that the test statistic may vary slightly depending on whether the two populations are proportions are independent or dependent, and hopefully it will be clear from the problem whether populations are independent or dependent. But if it's not clear on the exam, you should always ask about that, and I might be able to point you in the right direction. But let's look at an example here. So the proportion that we want to use in this case is given by this following formula, and I know this is kind of a complicated formula. We'll look at an example here, but P1 comes from the first population, P2 comes from the second population, and again, there are certain conditions that have to be met that are specified here. But let's take a look at this statistic closer. Since we are dealing with populations proportions, this will be a z statistic, so you simply plug in the values in here. So this would be the proportion of successes for population 1, proportion of successes for population 2, N1 and N2 would be the sample size of each one. One thing I should mention too is that oftentimes we will want to use what's known as a point estimate, sort of what's called the pooled estimate in this case, which will be denoted by p hat. So it's sort of what you get when you pool the observations together. And so the test statistic for comparing two populations then can be rewritten using this pooled statistic, where you're basically kind of taking the average of the two things written together. And in that case, the formula that we just saw simplifies to this. I'm not going to go through the math to show you that, but you can see that that does simplify. So you can see that it's a little bit less complicated than what we had on the last slide here. So we'll want to use this formula instead, where this p hat, again, is this pooled statistic. So just to look at an example here, and again, this, the procedure for this should be listed in your book somewhere in 11.1, the procedure I'm about to go through here. And I think in this case it is listed on the top of, or the bottom of page 531 and the top of page 532. So again, there's some conditions that have to be checked here. So you don't really have to worry about this formula too much. The main formula that you're going to want to use is this simplified form. But the first thing you want to do is make sure that the conditions are met. So again, for the problems, in order to use the test statistic we saw, the z-score we saw in the previous slide, you have to make sure that these conditions are met. Again, in most cases, it will be assumed that these conditions are met. But technically, this is something you should have to verify. And then again, it'll either be, in this case, a two-tailed test, left-tailed test, or right-tailed test. You'll notice in this case, though, that you have two different proportions in this case. And then you, again, will have to determine the level of alpha, which is, will usually be given to you in the problem. Again, unless otherwise stated, it will typically be 5%. And then you calculate your test statistic, again, in this case, using the pooled population proportion. So you calculate this number just as before. And then again, you can either use the classical or the p-value approach. So with the classical approach, you would compare this computed number to the z alpha level. You would either look up in a table or compute using StatCrunch. And then again, if the test statistic falls within the critical region, right, you would reject the null hypothesis. If you use the p-value approach, again, you can either use table 5 or technology to determine the probability value. And again, just as before, if the probability value falls within the critical region, in other words, if it's less than alpha, you will reject the null hypothesis, just as in the previous chapter. And then don't forget to state the conclusion, right, to state your answer in words instead of in symbols. And that's basically it. So the main difference is that the test statistic, the formula you're going to want to use is different. And again, like I said, this is on if you want to look in your book, the electronic version of your book, this is on page 531 and 532. So maybe just to look at a specific example here. So in this case, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. So they obtain a sample of 800. This would be your N1, and you have that 338 of them have internet access. Then you obtain another sample with 750, so that would be N2. This would be X sub 2. Test the economist's claim that the alpha equals 0.05 level of significance. So again, these are your x1, n1 values. You would use that to compute p1 hat and p2 hat. Again, verify that the conditions are met, which they are. And then set up your hypothesis. So the claim that you're making here is that the percentage of houses with internet access has increased, is greater than p2. And again, this is at the 0.05 level of significance. So calculate your pooled statistic. Plug your values into the formula. Again, the pooled statistic would occur here and here. Work this out, and you get the z value is 1.33. So again, using the classical approach, if you look that up in the table, a z statistic of 1.33 is over here. an alpha level, a Z alpha level, again the alpha level in this case was 0.05, corresponds to a 1.645 standard deviations from the mean. So this is not within the critical region, so you would not reject the null hypothesis, which would mean that basically the proportions in this case have remained relatively the same. So there has been no change. Again, you could use the p-value approach. In this case, if you calculate the p-value that corresponds to 1.33, the area of this region, again using technology or the table in the back of the book, you will get that the area here is about 0.09, which again is less than your alpha level of 0.05, so again you will not reject the null hypothesis. And then just make sure that you clearly state the conclusion, right? So there is insufficient evidence, again, to conclude that the percentage of urban households with internet access is greater than the percentage of rural households with internet access. Okay, so there's an example that will help you understand that. Another something that you might want to talk about here, again, that was for dependent or independent solutions. So remember, this formula again is for dependent solutions, but I guess what we want to look at here is the constructing and interpreting a confidence interval for the difference between two population proportions, and then we'll look at the dependent case. So in this case, to construct a population or a confidence interval in this case, again the conditions have to be satisfied, and again you basically have the difference in the two population proportions times your z alpha over 2, again because you've got two intervals in this case, times this formula. This will be very similar to the formula for the statistic here. So as an example of that, if you go back to the example that we did before, let's say that you want to find a 99% confidence interval. You want values for which you'll be 99% confident that the values hold. So again, you would just go ahead and calculate your proportions. Again, plug into the formula. You'll get negative 0.0310 for the lower bound and 0.0974 for the upper bound. So you can be 99% confident that your values are between those two regions, I guess is one way to interpret that, right? So to state this, you would say that we're 99% confident the difference between the proportion of urban households that have internet access and the proportion of rural households that have internet access is between approximately negative 0.03 and 0.01. Since the confidence interval contains 0, we're unable to conclude that the proportion of urban households with rural internet access is greater than the proportion of rural households with internet access. So that's an example of how to calculate the confidence interval in that situation. Now the next thing we want to look at here, which I'll talk about in the next video, so we already took a look at how to compute things where there were independent samples. Now when we have dependent samples, we will have to use a different test statistic, and I will save that objective for the another video. So, alright, well, as usual, if you guys have questions about anything or whatever, just let me know. Alright, thanks.